Hello and welcome back to my YouTube channel Biomathematician. Today we are going to develop a machine learning model for malignant and benign tumor classification using breast cancer Wisconsin dataset. We will explore how to implement logistic regression using Python and its popular package like scikit-learn. Scikit-learn is a package that comes with different built-in models for classification and regression purpose. So without wasting any more time, let's get started. First, we have to import all the necessary modules which we will be using to perform the classification and evaluating the model performance. So first we will import pandas and numpy for data handling. Then we will import the dataset, that is breast cancer dataset. Then train test split for splitting the dataset into training and validation set. Standard scaler for performing z-score normalization to rescale the dataset with the mean of 0 and a standard deviation of 1. Logistic regression as the model and classification report as the evaluation metric. So let's first explore the dataset. So we can see the dataset by this. So we can see that this data has a data entity which consists of an array. This array is a feature matrix. Then we have the targets, that is 0 and 1. So 0 means malignant and 1 means benign. Then we have the feature names, that is the column name for each of the column for feature matrix. So first we will reorganize these things as a data frame, this for simplicity. So let's do it. So here we have our column that consists of all the variables which we will be using for performing the prediction and training the model, and we have our class column which consists of the target label, that is 0 and 1. So 0 is for malignant and 1 is for benign. So then we have to separate the feature matrix. Once we have the data frame, we can separate the feature matrix and target label. So feature matrix will be represented by X, capital X. So we have to drop the class column, and everything except the class column will be the feature matrix. Next is target label. So target label will be represented by small y. So we have to select the class column here. So once we have done that, we can explore the dataset. So for that we will use the panel histogram for visualizing the distribution of feature matrix and bar plot for target label. So here is our paneled histogram showing the distribution of each column or each variable of the feature matrix. Similarly, we will create a bar plot for target label to show the distribution between target label. So here we have the bar plot. So we can see that there are around 350 entities of 1, that is benign, and 200 entities of 0, that is malignant. Next, once we have divided the dataset, we have to divide the dataset into training and validation set. So for that we will use train test split. So here test set will be 0.3, which will be 30%. So we will use 30% of the data as a test set or validation set, and remaining 70% will be used for training set. Next is pre-processing. So first we have to define the scalar, that is standard scalar. Next we will first train the scalar and fit, then we will transform scale that training data set. For that we will use fit underscore transform. So always keep in mind that we have to fit the scalar using training set only. So first we have to fit the scalar using the training set, and then we will transform the training set. Next we will just transform the test set. We will not fit here. So our data has been scaled. Now we can implement the model. So we will use logistic regression, as it is a classification problem. Here we have defined our model. So this will just be a simple model. Next we will do training. So for that we have to do model dot train, and we will provide x trained and y trained. So the model will be trained using the training set, that is feature matrix for the training set and the target label for the training set. So our model is now trained. Next we will predict the model using perform the prediction of the model using the test set. So we will do y predict. This will the predicted value of the predicted value of target label using the test set. So we have our y predicted value. So this y predicted ypred will be the predicted value of the predicted value for target label using the X test. So let's compare the predicted and the true value and evaluate how is the accuracy for the model we have just trained. So for that, so here we will give y test, that is the original y, and y pred, that is the predicted y. So here we can see that the overall accuracy for our model is 0.98. So it has a 98% accuracy, and for individual overall accuracy 98%. And if we see the F1 score, so for malignant class it is around 0.9, that is 98%, and for benign class it is 98%. So our model have performed quite well. I will attach the link for this notebook into the description, so you can see and apply it on your dataset also. So this is just a simple model. We will train some complex model also, and we will get deep into the model parameters also. Like here we have just used simple model, we have not included any parameter or did any hyperparameter tuning. So in the coming videos we will do that.